Hey guys, hope you guys are doing well. What I wanted to do today is kind of talk about lesson 5, get you guys started. I'm not going to be back for most of the week. I might be there Friday. I'm probably going to be out the full week though, to help my wife out. And so I just wanted to get going on this. I'm going to start you guys off on 5-1. You'll press pause. We'll go do 5-2. Press pause, 5-3, press pause, and then you go and do the problems. And then I'm going to go over the summary at the very end with you guys. So this section right here, there's a lot of things having to do with pyramids and building different shapes. This right here is the Transamerica building. You guys should know that it has a square base. Same thing up here. It has a square base for this top floor. And what's happening is we're going from this big square at the very bottom to this much smaller square. And of course I can't draw to save my life. You guys know that. And so what's happening here is we have this building being drawn, and this right here measures 53 by 44 meters. It's not a square, it's a rectangular base. Sorry, if I read the first sentence, it said it's a rectangular base measuring 53 by 44. What it's asking you here is what happens to the top floor, okay? What happens to the top floor? Ignoring the wings, what is the area of the top floor? Well, the area of the bottom floor is 53 times 44. What we need to do here is you guys need to find these two sides using the scale factor, which, as you guys know, the scale factor, you multiply each of these sides. So 53 times 0.32 is going to give us this side right here. Once you guys find it, you also need to find this side and then multiply to find what the area of the top floor is. And then you guys are going to give me a sentence. What I'd like you guys to do is please go ahead and press pause to go finish that problem. All right, I did just like pause. I didn't press a button. I didn't edit. I just stopped talking for a minute. This next problem, it's one that's also fairly similar to this. This one's talking about a triangle has an area of 100 square inches. So we have a triangle here. This triangle needs to have area of 100. So we need 1/2 base times height. So what do we want to make it? We go with whatever you guys want. Let's do 20. Let's do 20 as the base. Okay. If I do 20 as the base, I have 1/2 times 20 times what is going to give me 100. Well, half of 20 is 10. 10 times what gives me 100. Another 10, right? So we can make a triangle here, any triangle, and you guys are going to go through and you're going to answer all the questions that follows. The dilated triangle's area is 25 or 6.25. How do you do it? Remember, when you take the area is going to be the area length times width, or in this times 1/2 base times height times k squared. This is always going to be the area formula, and so keep that in mind when you guys are going through this. What I'd like you guys to do is please go ahead and answer all the parts that go along with this. And go ahead and press pause and finish off 5-2 for me. All right, here's the last part of it. An artist painted a 1-foot square painting. Now she wants to create more paintings of different sizes that are all scaled copies of her original painting. The 1-foot square painting. The paint she uses is expensive, so she wants to know the sizes she can create using different amounts of paint. Okay, I suppose the artist has enough paint to cover 9 square feet. If she uses all of her paint, by what scale factor can she dilate her original painting? Okay, remember the formula is length times width, or your area formula, times k squared. Okay? So I want you guys to keep that in mind when you guys are going through and you're dilating with the area. This k squared here is very important. With this painting, what we have right now is we have length times width and this gives us an area of 1. Okay, this is length times width, and it gives us 1. And she's going to try to scale it to figure out what's going to give her an area of 9. Okay, what did we end up multiplying length times width by? And that's the basic idea. What I'd like you guys to do is please go through, finish this table off after you guys answer question 1. And then you guys are good to go. You have all of these questions to go along with it. Try your best on them, and go ahead and press pause. After you guys will press pause on the video and then finish the problem. All right. As for the last part, you guys are going to skip the Are You Ready for More? Here is the lesson summary. If we know the area of the original figure and its dilation, we can work backwards to find the scale factor. If we know the area of the original figure and its dilation, we can work backwards. Well, the basic idea is when you guys know the area is 64 square feet of something, you know you have a scale factor of 8 because we're going from 1 to 64, so we multiplied by 8 squared. Whatever your number is that you multiplied by, you can always take the square root of it to find the scale factor. So for example, in the one problem where you guys had the length and width of a painting, that was equal to 1, and then you wanted to find what the scale factor was when the actual area was that, you had length times k, width times k, so you have length times width times k squared when you multiply these two things together. With this, we know length times width is equal to 1. So if you do that, we get k squared. This entire thing's equal to 9. And so if you guys go through and you take the square root of both sides, you find the scale factor is actually just 3. Okay. When you guys start to draw these all out from that same problem, the painting problem, you guys are going to see that the scale factor, as you go on, the bigger the area, the smaller the scale factor is because you're squaring it. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So what ends up happening is as the area gets much larger, the scale factor, as we're taking the square root, is going to not be growing as fast. That's why it curves downward. And this is represented by, once again, the square root of x. That's what this function right here is. This function right here is y equals the square root of x, and that's what it looks like. All right, guys, have a beautiful day. Have a good one. Bye.